let's talk about this one, okay? So this is really important for using the Laplace transform, okay? So look at that. Your function gt is equal to unit step function at point C, and you're going to multiply this function, okay? So by the definition of like unit step function, we can write like this way. Before C, it is 0, and after C, it will be just f of t minus c. But wait a minute, look at that. What is this notation means? T minus c. It is kind of like, do you remember like in the geometry or algebra? Like this is kind of like, translation, right? It is shifting c unit to the positive x-axis, right? So like, if I show you the graph of this one, it might be much easier, okay? Here we go. From 0, then like, here, let's say it is f of 0, then it is kind of like function, okay? So let's say this is y equal to f of t. Then what about uct f of t minus c? Here we go. Like before c, it was 0. Let me use like different color. Okay, it was 0, but from that point, it's the same function. Okay, this is uct ft minus c. Okay, so that point is f of 0 point. Okay, it is shifting. Okay, not cut, but it's shifting. Okay, with this one, we could have like really important theorem, which is number 10. If function f of s is the Laplace transform of f of t, then like Laplace transform of the unit step function at c times f of t minus c is equal to e to the minus cs times f of c, where f of s, where f of s is the Laplace transform of function f of t. And as I told you, not only Laplace transform, but you have to know how you can do like backward, which is inverse Laplace transform, right? So this like inverse Laplace transform is given here. Does it make sense? And these are really important thing. And as I told you, it is in the table as well. Okay, let me show you the table. It is number, there we go, number 13, right? So now let me give you a couple of example, which is concerned with this one, okay?